Welcome to our subscribers and new viewers of the channel. In this video, we'll walk you through the full process of recovering data from RAID 5 and RAID 6 arrays running on the Dell PERC 6i controller in a Dell PowerEdge R610 server. We'll show you what to do if the server fails or if one or more drives stop working, and we'll also explain how to regain access to your data if the RAID array becomes unavailable. Dell PowerEdge R610 server. When you power on the Dell PowerEdge R610, the post process appears on the screen. At this stage, you can quickly enter the BIOS by pressing F2 or open the RAID controller settings for the PERC 6i by pressing Ctrl+R when prompted. In its standard configuration, the R610 comes with 6 bays for 2.5-inch SAS or SATA hot swappable drives. To install a 2.5-inch SATA drive, you need to secure it in the appropriate metal drive tray, also known as a caddy, and then carefully insert it into the drive bay until you hear a click. Once the drive is properly installed, the activity indicator on the front panel will light up or start blinking, confirming that the controller has detected the drive. Creating RAID 5 on PERC 6i. After opening the interface, you'll see a list of physical disks and existing virtual disks. If the disks were previously used in another configuration, you'll need to clear the old settings before creating a new array. To do this, press F2, go to the Foreign Config menu, and select Clear. This step is important because leftover configurations can prevent the system from displaying all available drives when creating a new array. Next, go to the VDMGT section, which stands for Virtual Disk Management, and select Create New VD. From the list of available RAID types, choose RAID 5, then select the disks you want to include in the array. During setup, you can define the RAID size and assign a name to the array. You can also configure additional parameters, such as stripe size and the caching policy, choosing between write back and through. Other available options include Initialize, Configure Hat Spare, and Force Write Back with no battery, which you can enable if needed. Once you confirm these settings, the virtual disk will be created. It will appear in the list of available disks, and you'll be able to view its parameters in the Virtual Disks section. After that, you can exit the utility and continue booting the operating system. The storage is now ready to be used. Data recovery on RAID 5. Recovering data from RAID 5 requires extra caution due to how data and parity are distributed across the drives. If one disk fails, the array will continue running in degraded mode, but if another disk fails, it will result in complete data loss. If multiple drives fail or the array becomes inaccessible, you should immediately stop using the server to avoid overwriting data during automatic recovery attempts. If the PERC 6i controller fails on a Dell PowerEdge R610, you can use Hetman RAID Recovery to regain access to your files. The software automatically reads the controller parameters, analyzes the condition of the drives, and reconstructs the array structure while preserving the folder hierarchy. Before you begin, make sure to record the exact order of the drives in the server. Changing their sequence can make recovery much more difficult. After removing the drives, label them, for example with a marker, and connect them to a PC using SATA cables or a docking station. Once all drives are connected properly, you can start analyzing the data in Hetman RAID Recovery. If it's not possible to connect all drives at the same time, you can use an alternative approach by creating full disk images and analyzing those instead. We've covered this method in detail in previous videos on our channel. Once the image of the missing drive is mounted in Hetman RAID Recovery, the program will treat it as a real disk. Combined with the remaining physical drives, it will automatically reconstruct the array. This allows you to start the recovery process even if you have a limited number of available ports, while still maintaining data integrity at every stage. Launch Hetman RAID Recovery. After startup, The program will automatically detect all connected disks, analyze their condition, and attempt to reconstruct the RAID configuration using service data. In the main window, you'll see all detected disks and reconstructed arrays. These will be available for scanning, structure analysis, and data recovery. Select your RAID array and run the fast scan mode. Once the scan is complete, the contents of the array will be displayed. Select the files and folders you want to recover, and then click the Recovery button at the top of the interface. In the next step, choose where to save the recovered data and confirm the action by clicking Recovery again. Once the copying process is finished, click Finish. After completing all the steps, your RAID data will be available again and ready for use. RAID 5 Recovery in RAID Constructor. If the array is not detected automatically, you can use RAID Constructor and configure everything manually. This is necessary when damaged service information prevents the software from correctly reading RAID 5 parameters. In manual mode, you can define the drive order and specify the technical parameters of the array to prepare it for scanning. Keep in mind that RAID 5 is designed to handle the failure of only one drive. Thanks to parity, the program can reconstruct missing blocks of data and restore access to files as long as all other drives remain operational. However, if 2 or more drives fail, data integrity is lost and standard software recovery becomes impossible. To work correctly in RAID Constructor mode, you need to know the key parameters of the array, including the RAID level, drive order, block rotation algorithm, block size, and sector size in bytes. Without this information, accurate reconstruction is not possible. Open RAID Constructor and select Manual mode. Since these parameters are usually known from when the array was created, you can enter them manually. For RAID 5 on most PERC 6i configurations, the typical values are left synchronous, block size 64 kilobytes, and bytes per sector 512. Make sure these values match your original controller settings, as they may vary depending on the configuration. After entering the parameters, go to the Available Disks field, select the drives that belong to your RAID, and move them to the Selected Disks field, making sure to keep the correct order. If one or more drives cannot be connected physically, use the Add Empty Disk option to emulate the missing drive. Maintaining the correct drive order is critical. Any mistake can lead to incorrect reconstruction and make recovery impossible. If you don't know the exact order, you can determine it by trial and error. Change the order of drives in the Selected Disks list by moving them up or down, and update the reconstruction each time. The correct order will result in properly detected volumes and allow you to continue with scanning and recovery. Once everything is set up, click the Add button in the lower right corner to add the reconstructed array to the main window for further processing. Data recovery on RAID 6. Data loss can still happen even with RAID 6, which can handle the failure of 2 drives but does not guarantee complete protection. If the controller fails, you won't be able to access the data without replacing it. If replacing the controller doesn't solve the issue, use Hetman RAID Recovery. Let's look at a scenario where some files were accidentally deleted from a working RAID 6. Before starting recovery, make sure the destination storage has enough free space for all the data you plan to restore. If the PERC 6i controller is not working, remove all drives from the Dell PowerEdge R610 and connect them directly to a computer using any available method. It is extremely important to preserve the exact drive order. Each disk in RAID 6 contains specific data and parity blocks, so changing their order can corrupt files, break the array structure, and make recovery much more difficult. It's a good idea to take a photo or write down the drive positions before removing them. Automatic RAID parameter detection. After launching Hetman RAID Recovery, the program will automatically scan all connected drives and analyze their service metadata to detect the RAID 6 configuration. It will identify parameters such as block size and disk order and attempt to virtually rebuild the array in its original state. All detected physical devices and reconstructed logical volumes will appear in the main window, ready for analysis and data extraction. Once the RAID 6 configuration is detected, you can run a fast scan to quickly analyze the file system. This is especially useful if data was lost due to accidental file deletion on a working server. After the scan completes, the contents of the array will be displayed, including deleted files. Select the data you want to recover and click Recovery. In the next window, choose a healthy storage device where the recovered data will be saved and confirm the action. The program will copy the selected files while preserving their original structure. When the process is complete, click Finish. Now all previously deleted or inaccessible files will be available again on a working device. RAID 6 recovery in RAID Constructor. If RAID 6 is affected not only by file deletion, but also by the physical failure of 1 or even 2 drives, automatic detection may not work. In this case, use RAID Constructor to manually rebuild the configuration using the remaining drives and parity data. After launching Hetman RAID Recovery, open the main menu and select RAID Constructor. In the window that appears, click Next. Then choose Manual Mode. To configure the array manually, you need to specify the key technical parameters defined by the PERC 6i controller during initialization. These include RAID type, block order, block size, and bytes per sector. If the exact values are unknown, you can use typical settings for Dell PowerEdge systems: block order, left synchronous, block size, 64 kilobytes, and bytes per sector, 512. Entering these values correctly will allow the software to reconstruct the damaged array and provide access to both existing and previously deleted data. Next, build the array structure by selecting your RAID 6 drives in the Available Disks list and moving them to the Selected Disks field. Because RAID 6 uses dual distributed parity, recovery is still possible even if 2 drives are missing. The program will reconstruct missing data segments using parity information from the remaining drives, restoring the file system and directory structure. To emulate missing drives, use the Add Empty Disk option. Maintaining the correct drive order is absolutely critical, as any mistake will prevent successful recovery. If the order is unknown, determine it manually by rearranging the drives in the Selected Disks list until the logical volumes are detected correctly. Once the structure is rebuilt, click Add to move the virtual array into the main program window for scanning and recovery. After successful reconstruction, the RAID 6 array will appear as a ready-to-use logical device. Select it, run Fast Scan, and click Next to analyze the file system. Once the scan is complete, use the Preview function on the right side of the window to verify the integrity of recovered files, such as documents, photos, and videos, before saving them. Then select the required files and folders, click Recovery, and choose a destination to save the data. Confirm the action, and the program will copy all selected files, restoring your data in full. We created this video to demonstrate a practical approach to data recovery in complex situations. If you found this information useful, subscribe to the Hetman Software channel and stay tuned for more videos. Thank you for watching, and we hope your important data always remains safe and protected.